In this video, I'm going to show you how to isolate a critical value for a correlation, a squared correlation, a multiple correlation, a squared multiple correlation, a squared semi-part correlation documenting unique explained variance, and a proportion difference for independent groups. I come down here and press the button for the program, which is critical values 2. When I do that, a set of instructions on how to use the program appears in the description box. I'm not going to consider the material in the description box because I'm going to show you how to use the program here. Down here is the input values box where we provide information for the program to use to do its calculations. Let's consider first the case of a correlation. Here I'm going to use an alpha level of 0.05. I can change that if I want to. The type of statistic I'm going to focus on, I have to enter the numerical code for it. Those numerical codes are provided in the description box, but if I want a reminder, I can hit this toggle switch here to give me the codes. In this case, I'm doing a correlation, so I'll leave this at 1. And let's suppose my sample size is 75. And I want to know what the critical value for a correlation needs to be in order to obtain statistical significance. I click on Register Input. That generates the R syntax to do the calculations. I copy that to the clipboard. I open up R. Up here, I'll hit Control V to paste the syntax, and as it pastes, it will execute. The output is in blue and the input is in red. So in this case, for an alpha level of 0.05 and a sample size of 75, the absolute value of the correlation that I need to observe has to be at least 0.227 or greater in order to obtain statistical significance. Okay, let's go back to the input box. Now suppose instead I want to do a multiple correlation. Now I have to change the type of statistic to a 2 because I'm focusing in on a multiple correlation. Let's suppose my sample size is 75 and I have to indicate the number of predictors that I'm going to have in that equation. So in this case I have 4. I click Register Input. That generates the syntax. I copy that to the clipboard. I open up R. I hit Control V. And here are the results. For a sample size of 75, in order to achieve statistical significance at the 0.05 level, my multiple correlation needs to be 0.354 or greater. And here's that critical R translated into an R square. The R square needs to be 0.125 or greater. Okay, let's close this and go back. And let's suppose now I want to look at an incremental R square. So I'll change this to 3. Again, suppose my sample size is 75. And then I have a base equation with 4 predictors that yields a squared multiple correlation of 0.15. So I have to enter 0.15 here for the base equation. The number of added predictors that I'm going to look at in this case will be 1. And I want to know how much does the squared multiple correlation need to improve in my sample if I add 1 additional predictor for that additional predictor to achieve statistical significance at an alpha level of 0.05. I'll put 1 there because that's the number of added predictors. I click on Register Input. That generates the syntax. I copy that to the clipboard. I open up R. I hit Control V to paste the syntax. And here are the results. My base R squared is 0.15. If I translate that into a multiple correlation, i.e. by taking the square root of that, I get 0.387. If I add 1 predictor in order for it to yield a statistically significant regression coefficient, the R square needs to go up by 0.028. Or in multiple correlation terms, the increase needs to go from 0.387 to 0.421. Okay, let's close this. Go back to the input box. And now let's focus on a proportion difference for independent groups. I can go ahead and just leave the information in these boxes because these boxes are going to be ignored. All the information is down here. I need to specify the sample size for group 1. Let's suppose it's going to 100. And the sample size for group 2, which is also 100. And I want to specify the proportion for group 1, the P1 proportion, against which the test will be performed. If group 1 has a proportion of 0.50, what proportion do I need to observe for P2 in order to obtain statistical significance in my sample? I click Register Input to generate the R syntax. I copy that to the clipboard. I open up R. I paste the syntax. And here's the information. If the base proportion is 0.5, I need to get a proportion difference of at least 0.13 in order to achieve statistical significance relative to that proportion of 0.5. Okay, let's close this and go back up, and that's it. Thanks a lot.